All right, so before I go into the next examples, I want to we want to figure out a better way to do this without having to guess. All right, so integration by parts is essentially based on the product rule, right? And it's essentially kind of almost like reversing the product rule. So let's write down what the product rule says. So if we have two functions u and v, right, that are functions of x, and the derivatives are u prime and v prime, then the derivative, right, I'm going to write d dx of this product, uv, right, where u and v are functions, it's just the derivative of the first times the second plus the first times the derivative of the second. Okay, that's what the product rule says. Now let's just take this and rewrite it. Okay, I'm just going to rewrite this as u v prime, okay, is equal to the derivative d dx of u v, yep, u v, minus u prime v. Which is sort of what we did when we were doing those other ones. We found that this matched what we were looking for, and then we rewrote it. And then what did we do? We integrated both sides, right? So let's do that next. Integrate u v prime dx, okay, is equal to the integral of d dx of uv dx, right? And then minus the integral of u prime v dx. Okay, it's just integrating both sides. That's supposed to be an equal sign. All right. All right. So now, like we did above, in those previous examples, this integral of the derivative just gives us that uv function, right? So we can rewrite this as the integral of u v prime dx is equal to u phi minus the integral of u prime v dx. Okay, now that's essentially the formula for integrating by parts, but there's a little more concise way of writing that, because I can take this right here. So this is basically dv dx times dx. Okay, so I can write that as dv. Okay, and then this over here, if I combine this with this, right, those two things together, it's basically du dx times dx. So I can write that as du. Okay, so let me scroll down here a bit and show you the formula for integration by parts. Okay, so there it is. Voila. Now it'll make a lot more sense when we use it. Okay, so what we need to do is identify u and dv, and then what we do is we differentiate u and we integrate v or dv to get v, and just we're exchanging one integral for another. All right, let's do this though, because it really doesn't make sense until you dive in and do it. Okay, and there's a lot of well, I'll get to that. There's some tricks of the trade involved with integration by parts. So let me scroll down a bit more here and let's take a look at examples 1 and 2 again, only let's do them with integration by parts. All right, so here's what I'm going to do. I'm just going to demonstrate how this works, and then I think it'll make more sense. So what I'm going to do is I'm going to assign parts of this to be u and part of it to be dv. Now in this case I'm going to call this right here, I'm going to call that u, and I'm going to call the rest of it dv. Okay, so we're going to let u equal x, and we're going to let dv equal e to the x dx. Okay, we're just going to break it up into two parts. All right, and okay, so remember up here, let me see, maybe I should have this on the screen as well. Okay, we need du and we need v, right? Up here we need du and v. So we have u here, so we can find du just by differentiating both sides. So du is equal to dx. Okay. And then we can find v by integrating both sides of this dv equation. So v is equal to the integral of e to the x dx, which is just e to the x. All right, now we're just going to put it in our formula. All right, so our integral, which I just had here, is going to be u times v, so it's x e to the x minus the integral of v du. Okay, so v is e to the x and du is dx. And look at that, that's much easier to deal with, right? So we get x e to the x minus e to the x. And then, of course, plus c. All right? So let's try another one. All right, let's try another one. Let's revisit example 2 now. All right, so I'm going to break it into 2 parts. I'm going to let u equal theta. And I'm going to let dv equal cosine of theta d theta. Now that's the way it's written, and one of the hardest parts of integration by parts is just deciding what should be u and what should be dv. Now these are pretty straightforward, but I'll tell you more about some tricks of how to determine that pretty soon here. All right, so if I differentiate both sides, that gives me du is equal to d theta, right? And if I differentiate both sides here, I get v is equal to sine of theta. Sorry, not differentiate. I'm integrating both sides over here. Okay. So you can see one tip is that you want u to be something that's easy to differentiate, right? And you want your dv function to be something that's easy to integrate. Okay, so that's one tip. All right, so let's just plug it into the formula. All right, so we're going to take u times v, which is theta, sine of theta, minus the integral of v du, right? So that's sine of theta d theta. Okay, so that gives us theta sine theta minus a minus cosine theta, right? Because the integral of sine is minus cosine, so we get minus a minus, so it's plus cosine of theta plus c. Okay, which is what we got before. So, gonna let that sink in a little bit. Make sure you follow that, and I'll meet you for the next video. We'll go into this example 3, which you can have a sneak preview here below.